Hey everyone, and welcome. Today, we're going to jump headfirst into a topic that feels like it's been ripped right out of a sci-fi movie. But I promise you, what we're about to uncover is a deep, fundamental truth about our universe. We're going to explore quantum reality and seriously challenge the very idea of what it means for something to exist. So, let's get into it.
It all starts with that classic line, right? Beam me up, Scotty. So, is quantum teleportation just a dream for the big screen? Well, the real answer is so much more interesting, because it turns out it's not really about moving matter at all. It's about the very fabric of reality itself.
And to figure this out, we're going to leave the Starship Enterprise behind and head to a very real place, the Canary Islands. Back in 2008, a team of physicists set up this wild, record-breaking experiment, all to test the fundamental rules of the universe. This, right here, is where our story really kicks off.
Now, this wasn't just some theory on a chalkboard. This was a massive, real-world test stretching 144 kilometers between two islands. And the goal? To solve a quantum puzzle that had even stumped Einstein, who famously called the whole thing spooky action at a distance. Okay, so how on earth did they pull this off? It's basically a four-step dance. First, they use a laser to create these pairs of entangled photons. Now, you can think of them like a pair of magic coins. No matter how far apart you pull them, if one lands heads, you know the other instantly landed tails. But here's the crazy part. Before you look, neither one is heads or tails. Second, they split them up, sending one photon on a 144-kilometer trip across the ocean while its twin stayed behind. Third, they held that hometown photon in a long, coiled fiber just for a few microseconds. And finally, boom, they measured both of them. Now, this is where it gets really, really interesting, because they were testing two completely different versions of reality. The classical view, our everyday common sense, says each of those photons had a definite state from the get-go. Measuring it is just like flipping over a playing card. You're just revealing what was already printed on it. But the quantum view? Oh, it's so much weirder. It says the photon's state is totally undecided. It's in a kind of limbo until the exact moment you look at it. And when you do, that measurement instantly decides the state for both particles, even the one that's 144 kilometers away. So the big question is, which version of reality won the day? Was it the predictable, classical world we think we know, or was it the strange, spooky quantum one? Let's take a look at what the data actually showed.
And the results were just crystal clear. The quantum prediction was spot on. The moment they measured a photon on one island, its partner on the other island instantly snapped into a correlated state. Think about that. The universe decided the fate of both particles at the exact same time, faster than a beam of light could ever hope to travel between them. And we're not talking about a close call here. The result was confirmed by 16 standard deviations. To give you some perspective, in physics, getting to 5 standard deviations is considered a world-changing discovery. 16? That is just an absolute, monumental, undeniable certainty. So we know the spooky action is real. The question now is, what in the world does it all mean? Well, a result this huge forces us to completely rethink what it even means for something to be. It basically pushes us to let go of our classical intuition and embrace this radical new idea, something called a relational reality.
I mean, we're all used to this idea of a standalone state, right? A ball is red, a rock is hard. That's just how things are. We assume that objects have their own definite properties, totally independent of us or anything else in the universe. It's kind of our default setting for how the world works.
But this experiment is suggesting something way more profound. What if that whole idea that things have properties all on their own is just a useful illusion? You know, a mental shortcut that works great for big stuff, like baseballs, but completely falls apart at the most fundamental level of reality. And this brings us to this brilliant little twist on Shakespeare. To be, or to relate, that is the real question. And according to these experiments, quantum mechanics pretty much screams its answer from the rooftops. Relate. Maybe an object's properties aren't something it owns, but something that only emerges from its relationships with other things. And this, right here, is the core concept: relational reality. It's the idea that things aren't defined by what they are in isolation, but by their entire web of connections and correlations to everything else. That photon doesn't have a polarization. What it has is a polarization relationship with its entangled twin. Okay, deep breath. Let's bring this all the way back to our original question. If we're living in this weird new relational reality,
What does that actually mean for teleportation?
Well, the source material is pretty blunt about this. In this context, the word teleportation is sensational slough. Yeah, it's an exciting, flashy word, but it's based on an old way of thinking that this very experiment proves is wrong.
And here's exactly why. First off, you can't send a useful message this way. It's all random noise until you compare notes later using a normal phone call or email. Second, absolutely no matter is transported, not a single atom. And third, and this is the real kicker, the only thing that seems to be teleported is that standalone state, which quantum mechanics just told us doesn't even exist in the first place. You can't teleport something that was never there.
So let's get to the real takeaway here. This story isn't about teleportation. It's about a massive fundamental shift in how we understand existence itself.
This table just sums it all up perfectly. In the old standalone reality view, you imagine teleporting some property from point A to point B. But in our new relational reality, there's no teleportation needed at all. The correlation, that special relationship, was there all along. It just survived being separated by 144 kilometers. That's the real magic. And hey, this isn't just some philosophical navel-gazing. This idea that correlations are the real deal, this might just be the key to understanding some of the most powerful and bizarre quantum effects out there, like the insane processing power of quantum computers, or even how a single particle can act like a wave and interact with itself. So we end on this. That experiment in the Canary Islands didn't give us sci-fi teleportation. Nope, it gave us something so much more profound, a peek into a universe that isn't built on objects, but on relationships. And that leaves us with one final, absolutely mind-bending question to chew on. If everything is just defined by its relationships with other things, then what is truly real?